Hello. Hello. Okay, let me adjust the volumes. I think everything is fine. Great. So let's start with today's session, which is going to be a bit different, but I'm super excited with this project. Actually, it's something that it's been on my mind for some time, but never really had the time. And now I have a situation in the company where we are encouraged actually to pursue these ideas. Is kind of a hackathon time, and the idea is that we get something done in a month leveraging AI, and something that is impactful for the company, for the community. And I'm going to be working in a project called WordPress Docs Health Monitor, which I'm going to explain during today's session. And my plan is to work publicly on the project and share all the learnings that we have that we had during these first days. We've been working on this project for a week now, and there are a few cool things that we have learned that I would like to share with you all. So say hi in the chat if you are there, and let's start. I have a lot of things in my mind that I want to just throw without any specific agenda, any specific script. So, but I think there are cool things that can be helpful. For example, I think this is a great example of starting a project from scratch, and what we are trying to do. I'm working on this project with Jonathan Bossinger. What we are trying to do is to try to define things in a way and trying to setting up the infrastructure needed so we can delegate tasks to autonomous agents as much as we can without the complexity of setting up a specific machine, a specific VPS. So we've been kind of navigating through that, trying to find a good setup, and we are pretty happy with what we have so far. So let me show you. Let me first explain to you the idea of this project. So this is the repository, and I have a diagram somewhere that I'm going to share with you all. Let me see if I can find it. Yeah, here. Okay, so this is the idea of the project. The idea is that this can be used in any documentation site that documents code. So it can be applied to any technical documentation site. The idea is to automatically check the documentation pages and compare that with the actual code that is being documented, and detect any gaps in the documentation regarding APIs that are outdated, functions that doesn't exist, new functions that are not documented. So it doesn't cover for now like how well the explanations are, but for example, if you have examples in the documentation, it should check if those examples are valid with the latest version of the product we are documenting. That's the idea. So there are several pieces in this project. The first one is like the config part, where is actually like a config part where we define the specific site and the specific elements involved in the process. For example, here we will define the location of the documents and also the location of the repository or repositories that affect the final documentation pages. So that's the idea. With that, we have to generate a mapping, because for every documentation page we need to define the source code that affects that documentation page. So we will do that here. We will create like some matching, some pairings, an object that connects each one of these documentation pages with several files with code. And with all of that and any other configuration like prompts and so on, we will go to the analysis phase, where using Claude Code and some prompts. So my idea here is to just call Claude with some parameters, some specific prompts and some specific context. And the idea here is to do like two passes. A first pass to detect any inconsistencies, and a second round to double check that and to go into more details. And then with that, we will generate the results.json that we will display in a dashboard that will generate automatically. There are some extra things we want to also do, that is keeping track of the different results, because the idea is that this is triggered every week on a weekly basis, so we can get a history of how the health of the documentation site evolves in time. And in order to do that, we need another JSON. And also we need to implement the workflows, the GitHub actions to manually trigger this analysis and the generation of the dashboard, and also to schedule some cron jobs, so this is run automatically on a weekly basis. So this is more or less the idea. The main focus of this project is WordPress documentation sites. And we are going to start with the blog editor handbook. But the intention is that this can be applied to any documentation site. So the final goal is that we can get a dashboard that monitors the health of the documentation site for any WordPress documentation site, for any WordPress handbook, for example, the plugin handbook, the themes handbook, the CLI handbook, all the technical handbooks should fit in this project, and we should be able to get this dashboard. But also for internal documentation sites within Automatic, like for example the developer docs, for example this one. We should also be able to check how healthy this documentation site is, if there are any outdated information in it. Also the BIP this documentation site should also we should also be able to get this monitor. So yeah, I think the idea is pretty powerful, and yeah, let's see how it goes. So how are we working in this project? So the first phase, let me add here some. The first phase has been the analysis. The analysis of the idea. So what I've done here is I've been discussing with Claude Code. It's like having conversation with an engineer, and I've been like stressing and asking things and see how this could be done. From here, I got a plan of action. A plan of action that also plan of action that has led to the creation of some tasks. The creation of some tasks that has been defined as issues. Well, in fact, I want to say tasks. These are actually issues. And one interesting part, because we want this, well, the plan of action also key components. In this plan of action, I detected like these different key components, so we could create different issues for each one of these key components. That was the idea. So if we go to the repository, actually we have this here in the repository. There's a plan here. This is the first thing we crafted, a plan of action. So here the whole project is explained, and this is the result of my conversation with Claude Code. Here, keep WordPress hosted documentation sites accurate and up to date against the code described. This is a great explanation. Docs related to WordPress actually come from two kinds of sources. They come from Markdown files like Gutenberg. If we go to Gutenberg, the block editor handbook, which is the one we are going to use as a guinea pig for this project. Actually, this is a WordPress site, but the source content comes from the repository. So the documentation of the block editor handbook is tracked by GitHub. The advantage of this is that new content can be suggested via a pull request, and that enables any potential conversation about the change requested, and yeah, changes can be accepted or rejected, and yeah, there's a conversation that can happen using the same tools we use to merge code. But then there is this theme has some plugins, and there is some cron jobs that I think every 15 minutes check the markdown files in this project, which are here. This is the content of the block editor handbook, and it generates custom post types in this site. So for the sake of our project, we can just focus on this for now. We will check this markdown, and actually we will use this file as a reference because I think this is a pretty good way to define the set of documents involved in a documentation site. The nice thing is that each document has a unique slug that can be used as an identifier. It has a path, a location, and then a parent-child relationship, and then a title. So very simple but very effective, because we can uniquely define each one of the documents. So this structure, we will use that in our project. So we detected the key components, and then we created the issues. And the issues that we created are here, and we we were very specific about the form of these issues, because we want the project to be managed by autonomous agents. So in order to do that, we need to have clear acceptance criteria. So we can give this, we can say to an agent hey, Copilot, handle this. Or we can just directly, in fact, in GitHub, we can just directly assign a specific issue to, for example, this one is closed. This one was assigned to Copilot, and Copilot started working on it. But because the description of the task was very detailed, based on the previous research that we have done, and also because we added specific deliverables and a specific acceptance checklist, we can be very safe on the assignation of this task, because we can make sure that it's not going to do whatever it wants. We are being very specific about what we want for each key component. That's a result of our previous analysis, but I think that's important, because the Copilot within GitHub has the ability to run scripts, and it has the ability to write files. So we can, as part of the process of creating the issue, we can add tests, and we can make sure that those tests pass, and also we can check the types, and yeah, we can be very specific about what needs to happen in order to consider the task done. That's the main mindset, to create an issue that can be handled autonomously by an agent. So we worked a lot on this. So then the implementation part was actually the easiest part, because it was just assigning this to Copilot, and Copilot started doing things and generated this pull request. And this is the tasks that Copilot created in order to implement this feature. But then we can also talk with the agent directly from here, and we can say, okay, verify that the PR, because there is no output about that, we want to make sure that the acceptance criteria that is defined here in the issue, we want to make sure this acceptance criteria, we want to make sure that is passed. So we can ask, and it returns a full check of the checklist. And for example, in npm test, all the tests pass. Perfect. That's the first part that didn't require any extra plumbing. Second part, we really wanted to use Claude Code here. And we also, because we can work with Claude Code from the terminal. But we wanted also a way that we could use to work on this project remotely. So we wanted to work from the smartphone, or we also want to launch a task and just move to other things. So we don't want to be pending on the progress of the work. In order to do that, Copilot is a good way, but the quality, we are not so sure about the quality, so we implemented a few bots, Claude and Claude Opus. So by default, the model is Sonnet, but we have defined a second bot, which is Claude Opus, whenever we want to summon the bot to work with the Opus model, like the latest one. This uses the latest Sonnet model, the latest version of the Sonnet model, and Claude Opus uses the latest version of the Opus model. So we can summon and say, hey Claude, implement, well, the implementation is done, but we can say, hey Claude, review this code, because we rely a bit more on the Anthropic models. But also, a cool thing that we have implemented in this project is that in the Claude MD, we have defined an agents file with ownership of areas, because one problem that we have faced in other projects is that you are working on a specific area and then the agent starts touching other parts that doesn't belong to what you are working on. So we have defined specific agents to work on specific areas, and we can add here and we can iterate all we want. For now, we want to make sure that each agent only touches a specific part of the project. So we have a backend engineer, a front-end engineer, and a QA engineer. And we can leverage these agents whenever we summon Claude. So we have this an example here. We can say act as the QA engineer defined in this file and review this pull request. And Claude reviews the code as a QA engineer. Because we want to check the tests are meaningful, are not weak, and we want to make sure of that. In fact, I'm wondering if this definition is good enough. I'm going to work with Claude on that during this session. Maybe we can add more definitions, or no, I don't know. We can do progressive discovery, and maybe we can create a specific markdown file for each agent that contains, let me see, agents. Explore examples. Okay, these are examples. View examples on GitHub. Okay, we have agents. Okay, this is instruction for agents context. This is how can we find good agents? Let me see. If I go to GitHub, if I go to explore examples, development AI agents MD. How to write custom instructions with agents. Okay, working agreements. Yeah, this is something that we need to define maybe better for our project. Lessons from over 2,500. You are an expert technical writer for this project. Your role, you are fluent. I think we need to specify this. Agents, docs agent. This is the GitHub. Okay, so this is what I want. We recently released a new GitHub Copilot feature, custom agents defined in agents.md files. Instead of one general assistant, you can now build a team of specialists, a docs agent for technical writing, a test agent for quality assurance, and a security agent for security analysis. Each agents.md acts as an agent persona, which you define with firm matter and custom instructions. Agents.md is where you define all the specifics, the agent's persona, the exact tech stack it should know, the project's file structure, workflows, and the explicit commands it can run. It's also where you provide code style examples and, most importantly, set clear boundaries of what not to do. The challenge: most agents fail because they are too big. You are a helpful coding assistant. Yeah. You are a test engineer who writes tests for React components. Follow this example and modify source code does. Yeah, this is something more or less what I want. I analyzed over 2,500 agents files across public repos to understand how developers were using agents.md files. The analysis, okay. What works in practice? Put commands early. Put relevant executable commands in an early section. npm test, npm run build, pytest, include flags and options, not just tool names. Code examples over explanations. One real code snippet showing your style beats 3 paragraphs describing it. Set clear boundaries. Tell AI what it should never touch. Secrets vendor, never commit secrets. Was the most helpful. Okay. Be specific about your stack. Say React. Cover 6 areas. Hitting these areas puts you in the top tier. Commands, testing, project extractor, code style, Git workflow, and boundaries. So these are the sections that are recommended for the definition of the example of a great agent.md file. Below is an example of adding a documentation agent.md persona in your repo. So GitHub agents, docs agents. Docs saying you are fluent in Markdown, can read TypeScript code, you write for a developer audience, tech stack, boundaries. I like it. Boundaries, documentation practices, commands you use, real examples. How to build your first agent. Pick one simple task. Don't build a general helper. Pick something specific like writing function documentation, adding unit tests, fixing linting errors. Start minimal. You only need 3 things. Agent name, test agent, docs agent, lint agent. Description, writes unit test for TypeScript functions. And persona. You are a quality engineer. You are a quality software engineer who writes comprehensive tests. Okay, I like this. I need something like this for my project. Copilot can also generate one for you. Using your preferred IDE, open a new file and use this prompt. Copilot will generate a complete 6 agents. This article is what I was looking for. 6 agents that are worth building. Consider asking Copilot to help generate agent.md files for the below agents. I've included examples with each of the agents, which should be changed to match the reality of your project. Okay, docs agents. I'm especially interested in this test agent and the lint agent. So this one writes test, pointed at your test framework. Yes, PyTest, Playwright, and give it a command to run tests. So my doubt is if Copilot can run. Okay, let's start asking things to Claude. Git status. Okay, I'm going to clear. Okay, I have all of these changes to be committed because I have merged main and I have pending these changes. Okay, I'm going to meet this. State changes and merge changes. Okay, because I also solved sync changes. I also solved some conflicts from a previous merge, and now This is the add static HTML. This is related to this pull request. This branch has conflicts that must be resolved because I have merged the readme.md. And okay, let's solve that now as well. That was so git fetch. I don't need git fetch origin main and git merge main. Already up to date. Okay, so the conflict edit on the web. Current chain, I like this better. Prerequisites. Yeah, this sounds good. Commit merge. So I'm solving the conflict. And I should be good to go. No conflicts with base branch. And this is still a draft because right now I want to focus on some other things. Git checkout main. Perfect. Perfect. Async changes. So what I want to do is I was reading this article. So what I want to do is I'm going to start with a generic question like okay, this article explains how to create custom agents for GitHub. So the idea is that I can summon these agents. Questions that I have. Does this mean that if I define these agents, I can assign specific tasks to these agents? And secondly, if I define these agents, can I summon Claude to act as one of these agents when I ask it to review some of the PRs we have opened? Okay, let's see what it says. Starter template. Okay. Can you assign specific tasks to these agents? Yes, that's the whole point. You define agents persona and then summon them with agent name inside GitHub Copilot. Each agent has a focused scope. Okay. Okay, but if I summon my Claude bot as it's defined on the workflows, I should be able to say, Claude, act as the agent defined in any path that I want and do a review of this PR. That should be possible, right? Also, I don't really like having this agent definition in a format that is only useful in a GitHub context. Is there any way that I can define these agents in a more universal way, but at the same time using them inside GitHub as agents? Is there any reference internal that I can create? Okay, I don't think it has understood my question here. No, I don't like this. I want the opposite. But anyway, this is just extra stuff that I was curious about. Let's continue checking the project. So the idea is that we have the plan of action. From the plan of action, we have defined different issues with clear acceptance criteria. With clear acceptance criteria. This is an issue. These are the unit tests and okay. I'm going to try the project in the current, because right now we have implemented this, the schemas, these three parts. So the logic to fetch all the content, like the source docs and the actual code to check against, and also the mapping. Each documentation file linked to a specific code files. So we have that. Let me read the current README. Isn't this updated? Okay. README 1 hour ago. Yeah, this has been uploaded and expand README. Okay, let's start checking the type check. Cannot find module because I need to install the new dependencies. Okay, and npm run test. And we only have 5 tests. Pictures. So we have docs code mapper. Perfect. Both should exit clean. The test suite includes a git clone source test that is a local git repo under temp. Git must be on path. Okay, so npm test is adding. Okay, let's see what we can work with this. I'm going to start again to clean the context. Ah, 51 tests. Ah, okay. So there are 51 tests included in 5 files. I don't understand this error, so I want to have this clear. Error handling returns when manifest fetch throws a network error. The setter lines expect intentional output, not test failure. The two run pipeline tests returns a correctly formatted run ID and a result that passes without mocking fetch. Okay. So this is intentional, so no more to check here. Run the ingestion pipeline end-to-end. The bundled config targets the Gutenberg block API reference. 10 docs. Here's what it does. It loads config Gutenberg block API JSON and validates it against the config schema. So if we go to config, we can see here so the idea is that we have a config per site. So every site we want to check with this tool will have a specific config. And in that config, we will have the project name, we will have the source of the documentation, and then the code sources used to check the documentation. Okay. Fetches the Gutenberg manifest JSON, filters to entries where parent block API, and fetches each docs raw markdown. And where is this being fetched? I guess in okay, let's run this process. So clear, and if I do this npx fetches the Gutenberg manifest JSON filters to entries where parent and fetches each docs raw markdown. And where is this? It's not in GMP. Okay. Then I'm going to ask about this. I'm going to ask about the instructions here. Regarding this, I'm getting this. Give me more details about the process. Where the documents are located, for example. So I'm passing it the instructions of the README, the results of the because we are narrowing the scope of the project. Okay, the pipeline fetches this URL, which is the manifest.json. It filters where parent is equal block API. Okay, which returns 16 docs. Fine. Each docs markdown lives in the Gutenberg repo under. So if we click here, we should be able to access the markdown. Fine. Okay. So in TMP Gutenberg trunk. So if we go to because cd no, this part I don't get it. Two repos are cloned into TMP on first run. TMP. Okay. This part. Can you check if it's working? The repos are lazy. The git clone adapter only clones of first read file and the current. Okay, so what happens? So what does this script do? Fetches docs, hits the Gutenberg manifest JSON over GTB field. Okay. Where are these files being downloaded? They are fetching to memory. I see. So they are fetching to memory. Okay. Could we clarify in the README where any fetched content is being stored? A brief reference. So, okay, fetches the Gutenberg manifest JSON. Held in memory only, nothing written to disk. I like this. Resolves each doc slug against the mapping and prints the mapped code files, which is what we got here. For each file, we got primary, we got, yeah. Because the mappings are here. And for each document represented by the slug, we have like a primary connections, like the most impactful related code files related to this documentation page. Like we have like 3 levels: primary, secondary, and then more context. Yeah. Prints the mapped code files. So docs fetch fail 6, waiting for the bugger to disconnect. Okay. I want to ask that. No, the git clone code sources are not triggered by script. They will be cloned on first use once the validator is implemented. Ah, okay. So they are pre-runs reuse the cast clones under TMP. Expect 30 seconds the first time. I see. So this is the memory, nothing written to this in the fetches the good number. I only want this. Shallow clones. But step 3 indicates okay, perfect. Yeah, this is more clear. This is more clear. Okay, authenticates GitHub commit API calls for each docs. Yeah. Yeah, we need to add a GitHub token and Anthropic API key required for the mapping bootstrap helper. See below, not needed for the core pipeline until the validator lands. Yeah, this is the customization for a custom site. Bootstrap mapping with Claude. Curating this behind studios, the Bootstrap helper asks Claude to propose a code size entry for a single slug based on the doc content and the cloned repos file tree. Review and commit the output yourself. It's a dev time accelerator, not a runtime component. Okay. I want to understand this better. Explain me how this works. Because we discussed a specific implementation to extract with regular expressions the content of the markdown file. So is there any logic implemented to extract technical content like code and functions names and parameters from the markdown files in order to detect the related code files? Let me see if I can find the discussion. Okay, so this is the doc code mapper. doc source. Okay, this is to handle the source. Bootstrap mapping. Okay, this is the bootstrap mapping. This is the script that generates this, the matching of the docs source with the code. Load configs for the site fetches the Gutenberg manifest and resolves the markdown source, fetches the docs markdown content, instantiates all code source from config, calls listdir on each to get the file trees, calls Claude code with the docs full markdown content, the file tree from each repo. So it's not applying anything specific, because if we go to the discussion, the doc ingestion, I think. Hey, what's up? The loop, how you doing? I'm working publicly on this project to measure the health of documentation sites. I think we need a review up to the point to check that everything is going as planned. So is it for multiple WP projects or just WP Core Gutenberg? Okay, so the idea for this project is that, no, this should be useful for any actually this should work for any documentation site that documents code. That's the idea. The idea is that we establish a process that leverages AI to compare the content of the documentation page, extracts any code-specific content like function names or the arguments used or snippets of code examples, and with that information matches that with the related code files. So there is a logic of first pairing each document with the related code files, and this is something that we can also leverage AI to, and then passing all of that to another process that makes several passes to detect how updated the document is, and this process should also suggest specific actions to improve the docs, and as a result we will get a specific results.json, and then we will use to generate a specific dashboard. So the idea is that at the end, periodically the idea is that this can run on a weekly basis, and we can get this dashboard generated automatically. Yeah, yeah, but I think that it can be pretty effective because the first time it's going to check a lot of documents, but every week the idea is that only checks the affected documents for changes, so it doesn't have to go through all the files. Yeah, this is something I haven't figured out yet, but the idea is that it doesn't do the whole yeah, something like that. It checks the diffs, so I'm thinking out loud right now, but every week it checks the diffs of the Gutenberg repository, for example, and the WordPress develop repository, because we have this match. And let me show you the match. Is something like this. This is more or less the match. For every documentation page, we have like 3 levels of connections, so to speak. Primary one, like the most impactful ones, secondary ones, and then more context. So if there is a diff on any on these files, then we check the related documentation page. So we don't need to check all of them, only the documentation pages that are affected by a change in any of these files. So that's more or less the idea. And now we are on week 1 of this project. Let me share the repository so you can have a look. It's a work in progress. And we also, on top of that, besides the idea, we also want to leverage agents, autonomous agents, as much as we can. So we are learning on the process. But one thing we are trying to do is to define the tasks in a way that can be handled autonomously by agents. So one thing we are, and also we want to be able to assign tasks to agents and then go to work in another other thing. So we don't need to be in front of the computer. So yeah, we are exploring and experimenting. So the loop says, a week ago I tried something similar with a Claude skill. I copied Alex Karpathy's wiki digestion and turned project documentation in Obsidian visualizers. Cool. Do you have a link of that project or skill? I copied Alex Karpathy's wiki digestion. I don't know what that is. Is that a tool? I don't think I pushed it in a repo. Okay, so it's something you worked on your own. So what you were trying to do is to generate this diagram that is available in Obsidian with the connection of the different pages of. That's super cool. That's really cool. Yeah, that's really cool, and that's really useful as well. Because you can see the ideas that are most documented, for example, are most mentioned in the documentation side, the ideas that are less covered. So yeah, it's a nice thing. Yeah, push it in a repo so we can have a look at that. That seems like a really cool project to do. But yeah, with this project documentation, for this project to monitor the health of a documentation site, I would like to help improve the accuracy of the documentation sites, especially those targeted to developers. Okay, Karpathy says that LLMs digests information easier when the nodes are distributed in a balanced way in the graph. What do you mean by that? The LLMs information when the nodes are distributed in a balanced way in the graph. Okay. So the visualizer you want to build will also help you to measure how digestible a documentation site is for LLMs, something like that. Like if you have yeah, so if we modify your project documentation, yeah, that's really cool. That's really cool. That could be a really good addition to this project, because this is kind of related to the health of a documentation site. One of the triggers of this project is also LLMs, because right now LLMs discover information in code, but also in documentation sites. But if the documentation site is not updated, is not accurate, all the information the LLM is going to provide is going to be wrong. So I really want to avoid that for WordPress, and because WordPress is a community-run project, there are gaps in the documentation because there is a lot of work to do. And sometimes the only thing we need to have is a list of things to fix, because there are people that are willing to improve the documentation. So what I would like to have is a clear guide of what needs to be fixed in the documentation in order to be updated for every handbook. Yes, we hit outdated docs sometimes and it's hard to keep track. Yeah. So yeah, that's a goal. But yeah, there are several challenges in this project. The first one is to detect the parts in a doc that are susceptible. I can share with you the link for the tweet. Maybe want to study later. Whoa, this tweet went very viral. I wanted. It's kind of long. Okay, let's have a quick look. I wanted. Well, I have done something that I should not done in a live stream, like clicking a link live from someone in the chat, but luckily you're a good guy. Okay, he says, "Whoa, this tweet went very viral. I wanted share." Yeah, I was thinking of that. So it says, I wanted to share a possibly slightly improved version of the tweet in idea. In this era of LLM agents, there is less of a point need of sharing the specific one. You just share the idea, then the other person's agent customizes. You can give this to your agent and it can build your own LLM wiki and guide you on how to use it. Okay, I have a look later, but yeah, it seems interesting. Okay. I want to understand I want to do verification that we are progressing, taking into account the things that have been researched, because I opened here some discussions. Okay, I have the code ingestion, the code mapper, and the doc source. I created here, I think this is cool, a diagram with a view of the project that includes the schemas that are like the form of the data that goes from one piece to another. So we have the config for each side, we have the manifest JSON that represents each file in the documentation side. For each file, we can also go to GitHub and check the last time it was modified, so we can add this information to the doc source. So here is, okay, so this is already code source. Okay, so we do I need to clarify if the files are written locally, the ones that are kept in memory, because I think right now these markdown files are kept in memory, and then only when I call this, when I start this analysis phase, is when the code is triggered, which I don't know. I'm going to pass as a reference the discussions, like this one, copy link address, doc source, doc code mapper, and code ingestion. And also the issue. Taking into account these discussions, this issue, and the plan and the markdown files and the plan MD and docs and markdown files inside docs folder. Okay, what do I want to ask? I want to understand better how the fetching process works, because right now it seems that the markdown files are fetched but stored in memory. Does this make sense? Because for 10 files, I guess it's fine, but if we want to analyze 200 files, is this scalable? And second question, it seems the code in the repos are the code in the repositories is cloned on the analysis phase when the drift, what's it called? Yeah, the two pass validator when the Claude drift validator with two pass evaluation is triggered. Wouldn't it make sense to do this fetch and this clone earlier, like specifically in the code source part, the pipeline adapters, so the code and everything is ready when we start the analysis? I want to understand this better. Okay, so let's work a little bit on this. One of the things that I'm realizing working with agents is that now... okay. Is that most of the work is... this looks great, to be honest. I hope to see it running in Gutenberg's pipeline. Yeah, I'm not sure if it's going to be included in the Gutenberg pipeline, but it can be run outside of the Gutenberg repo. It can be a dashboard available. So my idea is that this should run in a repository using GitHub Actions in the infrastructure provided by GitHub. So just by setting a repository, and maybe I can also create like different branches. Well, I don't know, but at least for the block editor, I think in a few weeks we should be able to have a dashboard with an analysis that is run every week, and we can point contributors. A GitHub mirror would work. A GitHub mirror of what? Of the Gutenberg repository, you mean? I think, yeah, an outside repository with a dashboard we can point people to would work. Because this process actually internally, because the thing is that the documentation not only have to check the Gutenberg code, it also has to check the WordPress core code. So I actually need to clone internally the Gutenberg repo, WordPress develop repo, and if we need any other repository, it can also be added as a reference. But yeah, I think the path of less friction is to just do this from the outside, see how it works, see if it's useful, and then if after a few months or a year this becomes a great reference, yeah, I think it would make sense to make this more efficient. But yeah, for now, having this as an external repo, I think it can work. So yeah, let's see how it goes. Happy that you see this interesting. Okay, let's try to understand this a bit better. So, question 1, is in-memory docs fetching scalable to 200 files? Yeah, it's fine. So each doc object holds the raw markdown content, a few kilobytes each, plus metrics. So we're working with 2 megabytes, which is nothing for a node process. Okay. The design also already has bounded concurrency. Only 5 docs are fetched simultaneously, so memory doesn't spike for all. Okay. The actual bottleneck at the scale won't be RAM, it'll be network latency. So the fetching from the remote place. And Claude API calls. So it would be, okay, it will be 15. Okay, I need to check this. Okay, for this part, wouldn't it be more effective if we just clone the repository containing the source files? Because, for example, in the Gutenberg repo, if we clone the Gutenberg repository, the source markdown files are included in that repository. So from one run to another, we would just need to pull latest changes. So we won't need to do like different calls to fetch each document. Wouldn't this be much more effective? At least for those cases where the markdown files are included in a repository. Okay, let's continue. Question 2. Should Git cloning happen early in the pipeline, not necessarily at later time? This is a real design question and the docs address it directly. Here's the full picture. Current design, they say clone. Pipeline starts. Docs fetched in memory, code sources, instantiated, no clone yet. Mapper, resolve slugs. Validator calls. Okay. Your intuition. Vale, that's fine. Yeah, I understand. Sys where docs, that's the WordPress rule. This is worth raising as a phase 2 improvement. Okay, so for now it works. Okay, can we open an issue? In my mind, most of the sites will have the documentation source files in a repository. So this should be the default behavior. We clone a repo with the source files, and then we just pull the latest changes every time we run the process. For those sites where the documentation is in Markdown, we will implement some logic to scrap that content and generate the Markdown files. In fact, I think the easiest way to connect those sites is to just parse those sites from, like, get a mirrored copy of the documentation site that converts the production WordPress files with the in Markdown. So the idea is that I can have a repository that periodically fetches, periodically scraps a site and generates the Markdown version of that documentation site. So then I can use this site with Markdown files directly here. So summarizing, I think that we can assume that the documentation source files will always be in a repository. Yeah. Let me see the issue. Okay. Okay, fine. Okay, now regarding cloning the repository earlier or after, the case for eager clone is strong, and the architecture does actually hint at the discussion. Fetch once, cache back. Okay, so right now we are not really cloning anything. Because we haven't implemented this part yet, what we can do is just, I don't know. So yeah. So we are adding a note here. Okay. Okay, so what we have now is just fetching the markdown files, docs fetch, fetch 6. We need to check why these are failing. Okay. Okay, cool. So wrapping up, I'm going to stop the session here. Today I've been working on this project. With the idea of implementing a dashboard that allow us to check the health of a documentation site. The idea is that we get a dashboard with, I imagine this, a file per documentation page and a percentage of how healthy that document is based on the how up-to-date the documentation is. For example, the examples, references to functions, and so on. That's the idea. In order to do that, we need to implement a process to check the source files, a process to map the source files with the code files, then an analysis engine for the related files, documentation files versus the code that is being documented, and then with an outcome of this process, we will get a JSON that we can use to generate the dashboard. That's more or less the idea. And right now we are working on this, and yeah, we are working on this repository. We are trying to delegate the work to agents, and then we are reviewing the code and testing and suggesting new ideas. So yeah, that's more or less the process we're following. So hope this is interesting. I think that during this month, the streams I'm going to do are going to be focused on this, because this is a big focus for me this month. And yeah, I think this is a cool project to work alongside agents in order to get a project done from scratch. So yeah, see you next week. Although next week I think I'm going to do the stream in Spanish and the next one in English. But yeah, happy to see you here if you want to attend the stream in Spanish. Okay, Delup, thank you for the conversation. Very interesting the things that you have shared. And yeah, as always, if you cannot attend the streams, they are available in YouTube here. I'm going to share this link in the chat. And yeah, I will upload in the sessions there in case you want to check them later. And that's all for today, guys. Thank you for being there, and have a great weekend, everybody. Okay, bye.